Hey there YouTube. In this video we will be having a look at a robot that I built. That robot is shown on the screen. It's a two-wheeled robot, two yellow wheels, it has a blue body and it has a gray balancing wheel at the bottom. Okay. So this robot was made by me by making use of the ROS application. So ROS is an application that is used mostly in colleges. I don't know if it's used in the industry. People in colleges they make use of it to define robots and to write something like C++ to be able to control the robot. Okay, so that's about it. Okay, let's have a look at the code which I wrote to control this robot. I'm not going to go too much into the code because that's not my purpose of this. Okay, so now we have the C++ code. This is very familiar to most of us who work in C, right? You have a main function, and here you have a couple of things called ROS. These are things which is part of the ROS, say, library, and it has like functions and classes that you can use uh, from ROS, say when you write your C++ code. Okay, so you have a main function, and then you got two functions here. Okay, these are the important ones. One is called as to rotate the robot. It's called rotate robot, and the other is called move robot. Let's have a look at them. Right, here we are. This is the function to rotate the robot, and inside this function we have a data structure, and we populate this data structure with values. So there is a linear component if you want to move the robot in a straight line in x, y, or z direction, and there is an angular component. This is what you will use if you want to rotate your robot. Okay, in my case I want to rotate my, say, robot in the z axis by a certain value which I'm showing here. So inside the rotate robot I only want to rotate, right? So I just give the value to rotate the robot. Inside the move robot function, which is very same, which looks almost the same, here I only give values for it to move in a particular direction. Here I'm saying inside this linear thing, right? I want you to move in a straight line in the x direction for a value of, say, 0.1. So that's about it, guys. It's a very simple program. Okay, let's stop talking and let's start running the program next. Right, so here is the simulator. You can see the robot. I will have to build the package first. I'll build and compile it first. Cool, compilation successful. Let's run the robot. Program started. Cool. You can see the robot is moving first in a straight line. This uses the move robot subroutine from the C++ code, and now it rotates and it moves again. I think this is really awesome. I just wrote two simple subroutines, right? One to move and one to rotate, but you can see you can do so much with this. So just think about this. Okay, if you have a home or a house or something, right? If you have a robot like this which has this move function and this rotate function, can be used to scan an area, right? For a thief, or if someone is trying to break into your house, this serves like a guard dog of sorts. So this platform is really versatile, I feel. So it is like scanning a, say, a particular zone. You could use it in an office premises to scan an area, etc., etc. All right, all this is fine and dandy, but now I just use two subroutines that get blindly executed. My next plan is to put some kind of a sensor on the robot, like a camera, so the robot can see, or like a laser sensor. By using these two things, right? If the robot's camera sees an object, it will try to find out if it's a human being, if it's a dog, or if it's a car or a wall, etc., etc., and then it can act accordingly, right? If it is if the robot's camera is seeing a wall, if it goes close to a wall, it will rotate and travel in another direction. If it sees a person, let's say maybe a thief, if the robot has something like a gun or something mounted on it, it can just shoot the person, right? So there's so much we can do with this platform. I'm really excited. So in my next video, I am planning to take this patrolling robot. We'll call it a patrolling robot because it's patrolling, right? And we will put some cameras on it, and then I'll write some code to see how I can make the robot to do something smart when it gets too close to a wall, etc., etc. Then we will also see what we can do if the camera finds something which is dangerous. probably we'll make the robot to attack it or something like that. Alright, so we will do that in the next video. I hope you enjoyed this presentation, and it's really nice seeing this robot move and scan this zone. Alright, take care. Bye bye.